Hi there, this is a quick video hoping to demonstrate a proof of concept of a full server to Proxmox workflow. It's a little different from the current availability and migrate workflows that are available involving full server migration to pre-provisioned Proxmox virtual machines. This one doesn't require you to provision target machines, as most of that is done using a couple of additional steps, a little bit of scripting, bit with the graphical user interface. But it provides a many-to-one type migration or high availability workflow, similar to OpenText Migrate's and OpenText Availability's full server to ESX workflow. So basically, provisioning a new virtual machine, then disks are temporarily attached to a helper virtual machine. Data is then replicated into those empty disks, and then those disks are reattached to the virtual machine, and it gets spun up within a few minutes. So it allows you to migrate in less than 5 minutes of downtime, and it would provide high availability with a recovery point of seconds and a recovery time measured in less than 5 minutes again. So that's hopefully what I'm going to show you. I've been building this around a solution called DR in a box. Basically, that's just a small micro PC that cost about £168 sterling, and it's running Proxmox, and it's got 16 gig of RAM, 1 terabyte hard disk, and an N97 processor with 4 cores. But that's big enough to run a couple of virtual machines. I reckon probably 3 or 4 small Windows servers. Maybe slowly, but as a disaster recovery solution, that might be sufficient if that box was sitting in your data center somewhere, or your home of your managing director or something like that. As long as you've got broadband, it would work as a high availability solution. But it could be used to any Proxmox target environment, whether that's hosted or whether that's sitting on an old laptop or something like that. Okay, so the first thing I'm going to show you is my environment. So I have a couple of small environments in my home lab. One is my ESX environment, which is VMware ESX. I think it's VMware 7, but it would work with any different version of VMware. And in fact, the solution should work with any platform you might have as a source environment. So it could be physical, like a physical Dell PC or something like that. It just needs to be running a server operating system. It could be a Proxmox machine. It could be a Nutanix machine environment, as in a Nutanix hypervisor. It could be in public cloud. So it could be running in Azure or Azure Stack or Google Cloud or Huawei or Amazon or something like that. So the source server doesn't really matter where it is, as long as we can get to it and we can install the double take agent, which is part of OpenText Availability and OpenText Migrate. So I have a machine running in my VMware environment called W19 ESX source. As you can see, it's its host name there. It's just a small machine with a couple of processors and 4 gig of RAM, something like that. I've also got my Proxmox environment. So my Proxmox environment is running on that small box I talked about before. It's an Ace Magic something with an N97. You can see the spec of it is pretty low. You can see it's 4 cores, and it's got this N97, and it's running I think it's Ubuntu that they base it on, and then KVM on top of it, and then Proxmox on top of that. So I'm sure the solution probably worked with a KVM environment with a bit of work as well. As you can see, it's not doing an awful lot at the moment, RAM and CPU, so there's plenty of resource there available for doing migration to or for high availability. At the moment, there's just one virtual machine running on it, which is this Windows 25 Proxmox helper. So this is basically just a Windows machine that's running the agent, and it's going to be like a proxy server that we can connect some empty disks to. Now, maybe confusingly, I'm actually connecting into the Proxmox virtual machine. As I say, it's running Windows 2025 with an RDP session, which is I'm using Remote Desktop Manager to connect to that machine, so you can see the desktop of it. So that's why it's sort of locked out there. And I have various different things running on here, but you can see its host name, for instance, W25 PVE helper. So that's all sort of ready as an environment. So the next thing is we need to create a new virtual machine. So to do that, I'm going to run a command line on this machine, and maybe if I just clear my screen so you got a better impression of what's going on. I have a few different scripts that I might use for that, but I have created a script which will create a new machine. It's based on Node. It's just a Node.js, so it's JavaScript script that I give it an ID number for the new virtual machine I want to create, and also the name of that. So I'm going to call it W19 ESX2 PVE dash. I'll call it 1 for this case because there's no other ones on there. So I'm going to create that machine, and I'll happily share the script if you want it. But that should have created a new virtual machine for me with the ID number 206. So if we go back to the browser within here, we can see there's a new virtual machine that's just been created called 206 W19 ESXM. So the machine I just created. Now this machine, you could manually create it if you wanted to. It's just a case of creating a new virtual machine and just making sure that you have this sort of specification. So maybe you want a bit more memory. In fact, my script can cope with handling a bit more memory if you want to change the amount of memory or size of disks and things like that. But I find this is adequate for a default. The important things really are that it needs to be using UEFI for the BIOS. It needs to also have the EFI disk, and because I'm going to be using UEFI as well, so you have to create a machine with 2 disks. One's its hard disk and one's its EFI disk. And also in the options, you're going to need one of the settings needs to definitely be enabled, or it's not going to work, which is this QEMU enabled setting here. So with that, that machine's basically now ready to be used as a target. Okay, so now that we've got this disk machine that's going to be used, we need to attach the disk that we've created, which will currently be empty, to the helper machine. Now, to do that, I use a command line command from, it looks like it's a command line, so it's just basically going to say set machine 100, which is the helper. An additional disk going to be added to it, which is this VM206 disk 1. You can see that should match with what we've got here. And it's going to attach it as a SCSI device. So we'll do that just a second, and it's now attached that disk to it. So it's still there, but if we now look at the helper, you'll see it's now got this additional disk that we're going to be able to work with. And we need to run a couple of additional command line options on that using Diskpart in order to make it ready to act as a target. So I'll just again clear the screen from previous stuff I've been doing with it. And we'll just Diskpart. And when we list the disks on this machine now, and you have to be careful with Diskpart, just make sure you've got the right disks and so on, and you're working with the right one. We can see 2 disks now. There's disk 0, which is its system disk for the helper, which I know because that's the machine I'm actually running on at the moment. And we've got disk 1, which is the new 50 gig disk that we're going to temporarily attach to it and then replicate data into. So I want to select that disk. So we'll select disk 1, and there's a few commands that we need to run on it. I've got them listed out here, or mainly to remind me. Some of the letters are wrong here, so don't take it verbatim, but hopefully as I go through you'll understand what I'm doing. So I'm going to say I want to clean it, so that makes sure if there's anything that's on that disk that the new virtual machine has created when it's created that new empty disk, that's going to get wiped. Then we want to change the write attribute on it as well, because I have problems with that sometimes being locked later on in the process, so it's easier to remove that now. So disk clear read only, and then we need to create some partitions. So firstly we need to convert it to GPT. And that will have created some of the partitions already. I'll in fact create one partition. But if we look at the partition, see it's created this reserve partition. But now we need to create one for the boot system. So we'll do that using create partition. You can abbreviate some of these if you keep it to 4 letters, I think. EFI. And we want it to be size 100. So that'll create a 100 meg EFI partition. Then we also need to format that partition with a file system. We want it to be FAT32, and we want it to be done quickly, so it happens virtually instantly. And we'll give it a drive letter, although I usually have to give this again later on in the process, but let's do it now. So I'll give it drive letter equals S for system. We need to also create a Microsoft, I'm not quite sure, it's a Microsoft Reserve partition or something, but it's MSR. So we'll create, again, partition, MSR size equals 16. There should be a small one there, but without that, I tend to find that the job doesn't work. So you must change something on the file system to make everything work properly. Then I'm going to create a partition for the actual data, so the Windows file system itself. So we'll create that partition, call it primary, and we need to format that with NTFS. File system NTFS, and don't forget the quick here, otherwise you'll be waiting around for half an hour for it to lay the disk out in detail. Assign a drive letter to it, and we'll call it S, so W, because it's the Windows, and that should be enough. So we can quickly just check that if we use the command list volumes, it should show us all the volumes on this machine. Oops, what did I get? Just volume, not volumes. So you can see the CD-ROM drives that are attached there. Then it's got the C drive for the helper itself. Then it's got a couple of partitions. I presume that's the system one. Then you got the hidden one, which is probably that one I just created, MSR, although for some reason I don't have it from the other ones, but I've got this W and the S. So that will be my Windows partition, and that will be my S one. So these are the ones we've just created. We're now ready to start replicating to this machine. So this is the part where we're going to basically start replicating data from the C drive to the W drive, and we're going to use OpenText Migrate to do that, or we could use OpenText Availability, basically the same solution, just different licenses. And I have the OpenText console installed here, and in the console I've already added the two machines. So I have the source machine, which is running my VMware environment, and I've got the helper machine that's running in my Proxmox environment. When adding these in was just a case of IP address, username, and password. It's pretty straightforward. But once they've been added in, we would license the source machine. You only license the source. A migrate or an availability license will work depending on what you're creating, whether it's just a migrate service to Proxmox or whether you're going to be using it for high availability disaster recovery. But you don't license the target machine. That's quite important, or it won't work. So I'm going to choose the source machine. I'm going to choose to migrate it. The protect was grayed out because I'm using a migrate rather than availability. And I've got a choice of different wizards. Now these ones are great. You know, if you don't mind creating the target machine with a plain operating system in the Proxmox environment to start off with, we can overwrite it with a clone of your production service. Very easy. It's something that's been done by customers tens of thousands of times. But I'm trying to simplify it so that it's more like the full service to ESX and Hyper-V workflows, whereby we create the target machine, and it's more of a many-to-one type workflow. So I'm only showing one-to-one today. It should be fairly easy to create this using extra dive letters or mount points to make it many-to-one. But I'm going to go with the file and folder workflow. I'm going to see the file system that's all there. So in fact, I just need to click this box here just to select everything. So everything's going to be selected, but then we can make a few exclusions. So there's no point replicating the recycle bin. So I'll add a rule to exclude that. And I also don't want the page file. And there's probably plenty of other stuff that I could exclude here as well if I wanted to. If I was to look at the full server to ESX workflow, it does give a list of quite a few different directories and so on, including like program files where the Carbonite log files and things like that are. So, you know, I'll probably modify this in future versions of this video. I'm going to click next. I'm going to confirm that I want to go to the helper as my target. There's not much more to this. I mean, this is a workflow that's been around for over 25 years. As DoubleTake was created back in the late 90s. It's been doing this since day one, so I'm not really going to have to do anything sophisticated. All I want to do is make sure that any data from the C drive on the source goes to the W drive on the target, which is in fact the helper as well. So basically the data from the C drive goes to the W drive on the helper machine. And if I was doing this many to one, I'd probably have like W for one of my servers, V for another one, X for another one, and so on. So you basically split it up and just make sure the paths are right. And you're also using mount points and things like that as well. So these are stuff that I'm going to be investigating and adding into the product as I develop it. I don't need compression here, but I'll turn it on so you can see the effects of it because everything's on my LAN. But on a wide area network, it'll make a big difference to how much data sent over the network. We then validate it, and then we click finish, and it will now start synchronizing the data. So this is going to take a little while. We might get a few warning messages just as it starts up. That's quite normal, but it'll settle down. It'll calculate how much data needs to be sent across. It's already started sending data, and you can see it's already showing, it's already reduced the amount of bandwidth that it's needed to send that data so far. But it's going to take it probably about 15-20 minutes to synchronize. Just the speed of my hardware isn't the best. But the users are online, they're working while this is taking place. So if I was to go to my source server and have a look at it on the ESX host here, I've got a file on desktop, Andy. If I changed it, you can see the server's still live while this is all happening. If I change it to Proxmox, it's seeing that data. What we can also see because I'm using the helper as my RDP session here, I can actually look at the file system on this helper machine, and what you'll see is the drive letters. So you can see the W drive letters already got a little bit of data in there. That'll increase as we synchronize everything. But I can go into W. I can go to program files. Actually, I don't want to go to program files. I want to go to users. I want to go to administrator and desktop. And we can see that's that Proxmox file that I changed on the source machine. So if I was to maybe slide this, I think, I don't know, I might lose that image off the screen when I click on it. Yeah. But if I change it again back to Andy, by the time I switch back to my target, it's replicated it. So what DoubleTake's doing in the background is replicating, it's synchronizing all the files and folders from the source to the target, to the new target disk, but it's also replicating all the real-time change that's happening in the background as well. And that's true across databases and file system files, or anything that happens on the production server is being sent over to the target machine in real time. It might take a bit longer depending on the amount of bandwidth you've got, but once we've synchronized everything, it's going to be seconds behind the production server. So it is going to take it a little while to synchronize, so I'll probably speed up the next part of the session. I'll probably just stop my recording and start it again after it's synchronized everything. But you can see at the moment it's at about 14%. It's taking it a few minutes to get there. It's probably going to take it, as I say, 10 to 15 minutes. It might take hours if it was over a wide area network with a limited amount of connectivity. It might take hours if you've got gigabytes and terabytes and petabytes of data. But we're not breaking the laws of physics here, so it will take a little while to synchronize the data. But I'm going to just pause the video and I'll be back with you in a second. So after 15 minutes or so, it has synchronized the data. I've got a nice green tick next to it, shows the data is in sync. You can see the compression was quite good. And we're now ready to finalize the actual migration. So I'm going to stop the job. So data won't be sent from the source to the target anymore. So, best practice probably to shut down the source machine rather than just stop it like that. But then I'll have to start it up again. But if you stop it in a managed way, all the last changes will get sent across. You don't lose anything. I can then delete that job because I don't need it anymore. And then we're back to the command line. And we'll firstly just check whether the drive letters are stuck. And it's still got W and S there, so that's all good. So we can exit that. And we need to transfer across the boot system. So I'm going to use BCD boot, and I think the command is the drive letter where my Windows system is, which is W. And then we want /s, and we want to specify the drive where we want to copy the system files to, which in this case is the S drive. So S:, and then we want to make sure that the right BIOS is used. So we're going to use UEFI. There we go. So that command will transfer all the boot files across. So that's all good. And we're basically finished with the command net. So now we can finalize the actual migration. And to do that, I'm going to go back to the console. And we're just going to look at the Proxmox machine now. The first thing we want to do is detach the disk from the helper. So making sure it's the right disk, it's the 50 gig one we were working with before. And then the target machine has that disk already attached to it, but it's attached as a SCSI disk. And what we actually want to do is just detach it and reattach it as a SATA disk, because at the moment the drivers aren't available. So when I say detach, it just drops to the bottom here and says unused disk, but it's the same name as you can see. So we will then, you can just double click on it and we'll choose that we want it to be SATA rather than SCSI. And when we then are ready to boot it, well, there's one last thing to do, which one I keep forgetting to do, which is you need to go into the boot order in options, and you want to just change it so that SATA is the method that it's actually going to boot from, because otherwise you sit there waiting for it to start and it doesn't start. It's going to be quite embarrassing in a demo with lots of people. So I'm going to say console, and we'll start that machine. So with fingers crossed, we'll see Proxmox start up. Just take it a few seconds because it's going to be discovering drivers and stuff like that, because they are a bit different between VMware and KVM environments. But after a few seconds, we should see it will boot. I think it sometimes reboots again after it's got the relevant drivers it's found. But of course, this is the downtime. So everything up until the point that we stopped the double take job, the users would have been online. So installing the agent, configuring the job, synchronizing the data, everybody continues working on the production server. And it's only when you come to the very end, when the data's in sync and it's convenient to you, that we stop the job, delete it, and then make that change to reattach the disk. And as you can see, it's come online. So we can log into this machine now. The password. And you can see immediately on the desktop, you've got that Andy file that we created. And when you look at the name of the machine, it still has the host name of the original source. So there you have it as a workflow. It's a little bit basic at times. There's still quite a few rough edges. I'm sure there's a lot more I can do to automate it. Potentially build a front end, web-based front end, automate some of the other scripting, especially things like the disk partitioning. That could be done with PowerShell and maybe a bit more interactive. But I think it's definitely gives an option here to do disaster recovery to a Proxmox environment. And really, it's just a file and folder job from a OpenText Migrate or availability point of view. So it's pretty straightforward to support. So yeah, if you've got any questions, give me a shout. My email, aebs@opentext.com. Thank you very much for listening and watching. And yeah, let me know if you've got any questions.